Now that we have seen what are cosets and how to arrive at the left and right cosets, let's look at some properties of cosets. So given a group G under an operation and a subgroup of G, that is H, we can say H times E is equal to E times H is equal to H. That is, the subgroup H itself forms a left coset H times E and a right coset E times H. H times A is equal to H implies A is in H. So if multiplying every element of H by a fixed element A in G gives H back, then A is in H. H times A intersection H times B is either a null set or they are equal to each other, where A and B are in G. So, two left cosets are identical or have no elements in common. Similarly, we can also say two right cosets are identical or have no elements in common. A is in H times A. That is, every element A belongs to its own left coset, or we can also say every element A belongs to its own right coset. Order of H times A is equal to order of H, which is equal to order of A times H. So all left and right cosets have the same number of elements as there are in H. If H times A is equal to A times H, that is, the left and right cosets are equal for every A in G and for every subgroup H of G, then A times B is equal to B times A for all A comma B in G, which means G is abelian. So, in other words, if left and right cosets are equal for every subgroup and every element, the group is abelian. Now, if a coset H times A is a subgroup of G, implies A is in H. So a coset is a subgroup only if its representative is in H. Okay, somewhat of a new notation. Let's see. G is equal to the union of all the right cosets H times X, where X is in G, or we can say G is equal to the union of all the left cosets X times H, where X is in G. Or in simple words, the group is the union of all its left cosets or the union of all its right cosets. If H is in H, implies coset H times H is equal to H. So if H is in H, the coset H times H is just H itself. If H1 and H2 are two left cosets of H in G, implies H1 intersection H2 is a null set or H1 is equal to H2. That is, the two cosets are either identical or disjoint. If H is finite, then order of H times H is equal to H. So if H is finite, then each of the cosets have the same order as that of H. If H times A is equal to H times B, where A and B are in G, then A times B inverse is in H. So if two left cosets H times A and H times B are equal, then the product of A and B inverse is in H. If A times H equal to B times H, where A and B are in G, then A inverse times B is in H. So here we looked at left cosets. Here the same thing in terms of right cosets. So be careful about this two products. Let's look at this. H times A intersection H times B is a null set, or they are equal to each other. And this one, if H1 and H2 are two left cosets of H in G, implies H1 intersection H2 equal to a null set, or H1 equal to H2. So two cosets are either identical or disjoint. Be in a position to differentiate between these two. These two statements are saying the same thing, but the difference is that here we are talking of as specific elements A and B, whereas here we don't really care about which two elements are involved. Finally, each subgroup of G partitions G into cosets containing the same number of elements as that in the subgroup. So these are the properties of cosets. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.